So, am I audible now? I hope I'm audible now. Okay, sorry guys. Um, welcome welcome to this week's episode of Tech Niche. This is a legacy event by IEEE CS, where each week we are going to share our knowledge about a specific technical topic. So this week I'm going to share about the topic how the web works. So in this technique, we are going to see the background scenes of how the internet works and how the World Wide Web works. So we are going to see about the process of data transfer from our computer to the servers and so on. So this topic is extremely useful when you're going into web development because web development, we are going to create websites for the internet and it will be really useful to know the background process of how your code travels between your computer to the server and to the user's computer. And this is also a really vast topic. I'm not going into extreme detail. So I'm just going to share the overview. So this is what you're going to see. So the web or the World Wide Web is a service used to retrieve information from a client using a client-server architecture. So as you and the user sends a signal to the server through the internet. The data is then sent from the server by a set of protocols and is comprehended by the browser, and the web page is displayed on your computer. So this is what the topic is. So this is the agenda. So first we are going to see about packets, domain name system, TCP connection, HTTP request, server processing, HTTP response, and parsing. So these are all the steps or the process involved in data transfer through the internet. Now we are going to see what the internet is. Internet can be said as a network of networks. A network is the connection between one computer to another where it is possible to share data from one computer to another. So internet is all around the world, and the information is shared through billions of computers. So internet can be said as a network of networks. And internet is a distributed networking system, which means even if one computer is out of the network or goes offline, internet still continues to work. So this is one important topic about what kind of network the internet is and the transmission medium of internet. So as I said, the data is transferred from your computer to another computer. So let's say you're now in India and you're going to a website, and this website was made or posted by someone who's, let's say, in the US. So the data from their computer has to come to your computer. So the transmission medium actually used for the internet is optical fiber cables. It's actually physical cables, and the cables are connected from, in this example, US to your computer. But you don't actually connect wires to your computers. You use Wi-Fi. So that is a wireless network from Wi-Fi to your computer. But actually, I'm sure many of you have Wi-Fi at your homes. So there you actually have a telephone connection, and those telephones are actually wires. So those are optical cable fibers that is transferring your data as electrical pulses from the servers to your computer. Now, internet, I'll give you a brief history of the internet. Internet is developed in the 1960s by the US Defense Department to share network in a secure way. And there's a fun fact for you guys. The internet's first message is from UCLA, the university at USA, to Stanford. And the first message is login. The first ever internet message is login. But unfortunately, the Stanford computer couldn't receive the whole login message and it actually received only the first two letters, L and O, and the computers crashed. That's a fun fact for you guys. And there are some specific protocols involved to monitor or to standardize this process of data transfer. And the protocol is TCP/IP, which stands for Transmission Control Protocol and Internet Protocol. It is the foundation, and this is the most used protocol in the internet. Now, we are going to see the difference between internet and the web. When we use daily in a conversation, the word internet or the web, we use it almost interchangeably. Sometimes you say it's the internet, sometimes you say it's the web. But actually, the internet and web are completely different things, but related. So the internet, as we saw, is the physical connection between one computer to another, which facilitates us to transfer data. It is also said as a physical infrastructure. Now, web or the World Wide Web is actually software part which helps you which facilitates you to transfer the data. Internet can be seen as a physical part, and web is built on top of the internet, and it helps you transfer the data through specific softwares and protocols that you have seen that you're going to see in a few minutes. So now we are getting into the process of data transfer. Uh, Before you go into the process, you should know these basic three terms for computer networks in general. So those three terms are client, server, and the router. So client is the computer that needs the data or resource, you can say. So the client sends requests to the server, and this request is sent through the internet service provider. The server is the computer that is that has all the data, and every website that you need is stored in these servers, and these servers are located in some building called data centers. So each server is also a computer which specifically used to store all the information that you are going to need. And servers host websites, and sometimes one server can handle and host multiple websites, or some huge websites like Facebook or Instagram or YouTube have multiple data centers itself to assign each and every task of those websites. So that is the server, and this server is usually connected directly to the internet service provider or the internet. Now, this router is used to direct data. So why is this router actually needed? So let's say you have two computers where you are going to transfer data from one computer to the another. So you connect a wire between these two computers, and the data can be easily sent from the client to the server. Now let's say you have 15 different computers. So and you need to create a network where you can connect computer from you can connect the computers and send data from each and every computer to one another. So when you connect all the 15 computers through that wire, it can get messy, right? So there you can use a router which directs the request and responses to the specific computers necessary. And the router is a special type of computer that is used only for the direction of request or response. Another important need for routers is that when you connect the client and the server directly through the wire to transfer data, the information in the client and the information in the server computers are accessible to each other. So the client, when sending the request, can sometimes go into the wrong folder maybe, or retrieve the wrong information that might not be very secure and might lead to various technical difficulties. So when you use a router, the client only knows the location of the router, and also the client sends the information like, I need to access this specific server and this specific website. So the router will take that information and send it to the server, so to the specific server mentioned in that message. And the server again sends the response or the resources back to the router, and the router decides which computer the resource has to go. So in this way, the data security is increased through the routers, as there is no direct connection between the client and the server. Router is used for direct, and also the router is used to secure the information from the client and the server. So these three are the important computers in a network. So one is the client, One is the router, another is the server. Now we are going to see the process. So this is the process. There are 10 steps involved. I'm going to briefly explain each and every step that is involved in the process. So now the first is request initiation. So as I have explained, the client sends a request for information. So the client initiates the request and generally using a URL, you type, let's say, www.google.com or VTop you use, right? It's also a website. So you request, you use, there's a request initiation step. And now domain name resolution. So let's say you're going to youtube.com. So that youtube.com is a domain name. Domain names are actually used instead of IP addresses. Now, address is a specific name or a locator or an identifier each computer that is connected to the internet. So your computer, my computer, any computer that is connected to the internet has its own IP address, which is used to locate the specific computer. So youtube.com or the website or the server that has the website has an IP address. So now this domain name is used instead of those IP addresses because generally IP addresses are a string of numbers. It will be something like 12.345.268.331. So obviously we can't keep the string IP address for every single website that you have to go to. So that's why domain name is used and some processes involved in this domain name resolution. Now, after this is all done, after you find where you have to give the request to, you have to establish a connection between those two computers which need the resource and which has the resource. That's step 3. Now, you have the step 4 is HTTP request. HTTP is a protocol that is used to facilitate transfer of resources or you can say that it facilitates to search the resource in the specific server and then send it to the client properly. We have to give a HTTP request to the server for you to get the information. Now, step 5 is web server processing. After the server receives the HTTP request, the server does some processing where it has to go to like each specific place where it is stored. And there are few steps involved in that also. After the server finds all the information where it is stored, it sends a HTTP response back to the client saying that, hey, I have found this particular website or it is here. And send it. After this, the data transfer actually happens. So the data transfer happens through bits, through these optical fiber cables as electrical pulses to your computer. Next, there is client side rendering because you don't receive actually as a file or data that the web browser can come. So after it comes to the client, the web browser has to do something, has to compile the data and present it in your screen. And now there is a resource loading and then page completion. So resource loading is where first it will compile it everything together and then it will run that program. The browser will run your program and after that the browser will specifically it's a website. So if you know about web development, there are like HTML, CSS, and JavaScript. And then if there's backend, you have data like you use PHP or Ruby on Rails and all that, right? So after that, the page completion is where first HTML is loaded, and then CSS is loaded, and then JavaScript is loaded, and then whenever you click on something, your PHP or like your databases are you loaded to give you particular information. So that is the page completion process. So these 10 steps are involved in the process, the whole process of data transfer. I'm going to give you a explanation about step 2, that is domain name resolution, 3, establishing a connection, HTTP request, web server processing, HTTP response, it from 2, 3, 4, 5, 6. I'll give you all the steps involved in these processes or in these steps. And then I'll give you a little bit brief about parsing, which is involved in page completion and resource look. So before you go into the process, you should know how the data is sent or in what form the data is sent from the server to the client. So it is sent by a form called packets. Now, what are packets? Packets is a small segment of a large message. So data sent over computer network, such as internet, is divided into packets. These are then combined by the computer or this device that receives them. So your website is like it is a very big file, right? So when you transfer that through continuously or as a big file from one computer to the another, theoretically, it may be possible, but actually, when you use in practical purposes, it is quite difficult and sometimes not possible at all. So, those data or that data is fragmented into parts, small parts called packets. So, these packets are sent through the internet, and each packet will have the information about what number it is. So, let's say for example, some web page is divided into 100 packets. So the first packet will know this is the first packet. And second packet will know this is the second packet. And what packet follows the second packet, and so on. And the last packet will know I am the last packet and I don't have any other packet after me. So these packets are sent through optical fiber cables. And when it receives or when it reaches the particular destination, it assembles together. So for the first packet is first received, and then the first packet has the address of the second packet, and by that the second packet also loads. So by this the data is the web page is sent from the server to the client. So what is the need for these packets? Why can't you just send everything up together? Because see, you are splitting it or adding it, it gets complex. Why do you have to make things complex, right? The reason for that is theoretically it is possible for a computer to send data to another computer in form of long unbroken bits. So let's say bits are combinations of zeros and ones. Okay, so these bits can be like it might have like I don't know a bit size or number of bits like 10,000 or 100,000 bits. So it can come in the same line through a same cable. The problem is when only two computers are involved and one cable is involved, it is fine. But if there are multiple computers involved, uh, till the complete bit segment travels from the server to the client, the other computers or the other networks cannot use a particular cable, and then it has to wait for completion of this data transfer for the other second data transfer to happen, which is not quite efficient if you consider hundred or thousands of computers working together. And another reason is the data packet usually chooses the fastest possible route for it to reach from the server to the client. So if one route is occupied or if you have traffic, so traffic is a technical term where too much or too many computers are using the same specific cable to transfer data. So when there's too much traffic, this data packet will go to or switch to another route where the traffic is less. So it's kind of like a shortcut or maybe a long cut if you think that it's longer. So that is how the packets are assembled to your computer. And this is why the packets are extremely useful. Now, you know what are packets and how it is assembled or sent from the server to the client. Packet switching. So internet is a packet switching network. As I have explained, packet switching refers to the ability of networking equipment to process packets independently from each other. Packet in itself is an independent identity. So it has its own header, like I am this packet or I am this type of packet, and it has its footer saying that I am following this, or this packet is following my arrangement. And now this packet are individually processed, so it is not dependent. It is an independent identity, so that way it can travel into many different parts and are assembled together. So parts are I have said parts multiple times. It's basically just different optical fiber cables taken by each packet for it to arrive at a particular computer. Now, I told you, right? Packet has a label. It knows which number it is and what packet follows it. So I'll tell you the structure of the packet. So packet has a header. So header is a label of stocks which provides information about its contents, origin, and destination. All network packets include a header so that the devices that receives them knows where the packets come from and what they are for and how to process them. So every packet has a header. So this header contains information about origin, so which computer or the IP address of the client computer, and it knows the destination. So let's say a packet says sent from the server to the client. So the packet will have a header, and this header will have the IP address of the server, the content type, which is what kind of content this packet is carrying, and then its destination. So they all packets uniformly contain this header so that it is easier to assemble them properly to display the particular website that it also has a payload. So it consists of two portions, the header and the payload. The header contains information about the packet, as I have just said, the IP addresses and the length and everything. The payload is the actual data the packet carries. So let's say you need an image of a house. So the image of the house is split into small packets of particular bits. So the first bit will have a header saying that I'm from this server going to this client, the IP addresses of both. And then the content will have the first few bits of the whole image. Now, uh, then the whole image is sent to the client or to the computer that needs the photo as bits. And it is after every data packet reaches the client. So after the last data packet reaches the client, it assembles together and the image is displayed in the client's screen. So this is the structure of the packet, which enables the packet to act independently, so that it can be processed independently to send through the optical net. Now, packets and protocols. So I have said in the beginning that there are particular protocols involved to send to facilitate the data transfer process. So how are these packets and protocols actually related? So protocol, as I said, is a standardized way or set of rules to follow and interpret data so that the data is sent smoothly. So some protocols add headers to the packet. So packet is actually data. Some protocols add headers to the packet associated with the protocol. Meaning, uh, let's say there is uh, there's a TCP protocol, right? So this TCP protocol in that packet, in the header, it will label this as this packet uses this TCP protocol, and this has to be transmitted using this TCP protocol. And at minimum, most packets that traverse the internet will include a TCP header and an IP header. So, which means that uh, not only the packet will have information about the client and the server's IP addresses, it will also know what kind of protocol that particular data packet has to follow while transferring or while going from this client to the server or vice versa. So sometimes the packets or some specific protocols might also include footers at the end or trailers at the end of the packet. So header usually goes at the front and footers and trailers usually go at the last. So these will have additional information depending on the particular protocol. So I'm not going to detail what the specific information for each protocol will be because that will be too long. I'll just give you an example. So ESP is a specific protocol called the Encapsulation Security Payload, where this protocol attaches additional information about that protocol to the trailers and footers of each data packet or each packet. So this is how the packets and protocols are related. So I'll I have said a lot. I'll go to a overview. The packet is it's a small segment of the huge data that you are going to that is transferred from the client or from the server to the client. So packet is a small part of whole data, segmented data. Now packets have information in them regarding the IP addresses of the server and the client, and it also have the content or the bits of the actual data that you need to transfer. Sometimes the data transfer is managed through protocols. So packets will also contain information about the protocol, about what protocol or what rules it has to follow while going from server to the client. So this is all about packets and protocols. Now, this is some additional information. So an IP header is information about this. It will also have information about size and how long network routers should continue to forward the packet before dropping it. And it may indicate whether or not the packet can be fragmented, include information about reassembling fragmented packets. So the header. So in that specifically, it will contain how to reassemble data. Should I drop this data if it takes too long, or should I continue to send through the internet, and so on. And there is a term called datagram. Datagram is a segment of data sent over a packet switched net. A datagram contains enough information to be routed from its source to its destination. By this definition, an IP packet is one example of a data. Essentially, datagram is an alternative term for packet. So instead of packet, you can also use the term called datagram. It is a segment of data over a packet switch network, and it also has a header, the payload, and sometimes trailers and footers depending on the network. So if you remember the 10-step process I said, the first one is requesting. The second one is domain name system or domain name resolution. So domain name resolution is basically you type a URL through, or you type a link in your computer. Let's say YouTube, www.youtube.com. That is actually a domain name, and this domain name is it indicates a specific IP address. IP address is the uh, address of a computer connected to the internet. And this resolution has to happen for the computers to know which computer to actually go to in search of this data. So this domain name system is the process involved in the domain name resolution. So domain name system, I'll explain what happens when you type a URL into your computer. So you're going to type in this, let's say you're going to type www.google.com. When you type in this URL in your computer, in your search bar, even if you a dot is added at the end of the URL. See here, www.google.com, another dot is there. Even if you add it or not add it, it is added by default by your computer. And this dot is called the root of the internet namespace, or simply the root. This root is very important. So your computer or your operating system or your browser will resolve this root first. It will go to your memory, the computer in your computer, and it will go to this cache. This memory is called cache. It will see if it is already stored in this cache. It will see if the domain name if it is already being used, and it will search for this particular domain. If it is used, it will just follow the same thing and then display it. But if it is not used, what will it do? So it will go to the top level domain. Top level domain or TLD is called uh, this is the in the end of the URL. So you'll see .coms, .ins, .gov, .gov. So these are all called top level domains. So this top level domain name server is called the name server. So these will, let's say there is a .com top level domain name server. So this name server will contain information about all the .com websites available. So if first you type the URL, a dot is added, that is called the root, and your computer will go to the operating system or operating system's memory or the cache to search if it is already available in your memory. It has already been used. If it is not there, it will resolve. So resolving happens from the last of the from the last part of the URL called the .com, .gov, .in, some so on. So this is called the top level domain. So after this, in this example, I've taken .com. So it will go to the .com domain, TLD name server. It will search, it will ask TLD name server if you have the specific website. So if it has a website, it will show it to you, or it will, or even if it doesn't know, it will definitely know where to find the authoritative. These authoritative servers will these authoritative servers will show you, say, let's say www.google.com. First, you're going to the .com, and these servers will have all the uh, right, and it will know where to find the specific website. So here, it will know where to find the google.com websites, and that google.com websites will be stored in some server called authoritative server. So this authoritative server is the last stop of this domain name system. So there you will find information about that website that you're looking for. After this, it won't then what your computer will do is first it will go to your memory cache, and this memory won't have it, but it will know where to find the .com servers. It will go to the .com servers. It will go, and the .com servers will point it to the authoritative name servers. And after it reaches the authoritative name server, it collects information from all those servers. So it's actually another concept. So I'll say briefly. It kind of bundles up. So there's a first layer. That layer is the .com layer. That layer is the memory layer, and then it will go to the TLD layer, and then another layer is formed called the authoritative. Now, while coming back to the computer, first it will resolve the authoritative layer. It will open the authoritative layer, and then it will open the TLD layer, and then it will open the your computer's layer. So it will do a reverse process. It will carry all that information, go to your computer, and it will resolve it one by one for you to know. For you to know how for the computer to know the IP the server that's storing the IP address. So it will resolve this complete URL within less than the amount of time you're going to blink your eye. The first, so this is the process involved in resolving your domain name and finding the specific IP address for the specific location they're looking for. Now, there are there's something called queries. So queries is asking for data. So asking questions, right? That's a query. So there are three types of queries involved in resolving this domain name. So one is the recursive query, one is the iterative query, and one is the non-recursive query. So a recursive query is something that this kind of query will demand an answer. So it should know if you use this type of query, it has to receive some response. It should either receive, yes, I have this, or no, there is an error. So this is a recursive query. So when you go to your operating system, and if the operating system doesn't have it, it does not, it has to know whether it is there or not there by either yes, I have this, or no, I don't have this. Now, iterative query is something, uh, it will tell you the uh, most relevant answer for the query. So if the query DNS server does not have a match for the query name, it will return a referral to a DNS server authoritative for a lower level of the domain name space. The DNS client then will make a query with the referral address. This process continues either until either an error or time occurs. So I'll explain it. In an iterative query, you ask for this particular, let's say, .com, and if the .com server doesn't know, unlike recursive query, it won't just say yes I have it or no I don't have it. It will say I don't know where I don't have it, but I might know where I have that resource. So this is not an exact answer for whether you have it or not. It is a full answer or an answer that's close enough to that query asked. So that will be given in an iterative query. So then it will, like I have explained, the .com service will show you to the authoritative names, right? So now that information will be taken and it will go to the authoritative names. This is the iterative query. No, now for the non-recursive query, this will occur when a DNS resolver client queries a DNS server for a record it has access to, or either because it's authoritative for the record or the record exists inside of its cache. Typically, a DNS server will cache DNS records to stream service. So, hmm, excuse me. Um, for a non-recursive query, so this will happen, which means it will definitely have, or the server will definitely have the answer for the query, or it will definitely have the websites in this case. So this will happen in the authoritative name service because the authoritative name server contains information about the URL you're looking for. So in this non-recursive query, uh, this information, yes, I have it, or the information itself, the whole data itself is sent back to the client that is asking for the DNS or for the domain name. So these are the three types of queries involved in domain name resolution, which can be, it's not like for the whole domain name, only one type of query is used. Different queries is used for different processes. So recursive query, if you want to know whether that server has it or not. Iterative query is when you have to find it anyhow. So it will one by one go to the server. First, it'll go to .com servers. It will gain information, and then it will gain information about the authoritative name servers and so on. For a non-recursive query, if the server doesn't have the information, it will again go from the beginning. So the process will start from the beginning, and then it will go to a different server where it actually has the information. So these are the three types of queries involved in the domain name resolution. Now we are going into the next step of the process. So I'll again refresh the process once again for you guys. So the first step is the request initiation. The second step is the domain name resolution, and I explained it right now. Now the third step is called the TCP connection. So the TCP connection, you resolve the domain name, you resolve www.youtube.com, you know where to find the youtube.com, you know the IP address. Now, after you find the IP address, you have to establish a connection to transfer data. So this connection establishment is done by TCP, Transfer Control Protocol, and I am not going to detail about what the protocol is, but I'll show you the steps involved. So establishing a connection involves three steps. So this is called as the TCP three-way handshake. So this handshake is done, or this process is done to establish a firm connection between the client and the server. So there is a I'll tell you some basic flags involved. So in the TCP connection, there there's a TCP segment structure. It's a virtual structure, and it has different segments, different headers, different flags, and everything. Now, for this TCP three-way handshake, you need to know about two flags called the SYN flag and the ACK flag. So first, what happens is the first step is synchronize. So your web browser, the computer, sends a request or sends the message, synchronized message, setting the SYN flag as one to the server's IP address and port 80. This port 80 is actually a virtual place or the place in the server where some so it will have, for example, you need websites, so it will have a specific port for like HTML stuff, and you need, let's say you need applications, so it has a different port for applications where you can find the APIs involved and everything. So here, since I'm going to talk about websites in general, there generally it goes to port 80, and it is sent to the port 80. This is called as the SYN packet. So this indicates that the client wants to send or wants to establish a connection. So the client will be like, "Hi, I want to establish a connection, and I'm setting this SYN flag as one. Like it is a verified thing. Uh, so it's set as one and sent to the server. Now it also has a specific address of sort. So it's a 32-bit number. That is, something like an address of this packet. Again, you have to go into the detail of the TCP segment structure. The second step is the SYN called as synchronized acknowledge. After the packet or the message, synchronized message is sent to the server, the server will go to the port, will check everything, and then say this okay, that I am okay to establish this connection for you to send data from my side to your side. So there, what will happen is, it will again it will set the AC, it will have something called the ACK packet, acknowledge packet. So the server will set this acknowledge packet flag as one. One means, yes, I am okay to acknowledge this connection. And this packet is called as a SYN. And this packet is, the ACK packet is, ACK flag is set to one, and it is sent to the client. Now, again, this client, what it will do is, it will send the ACK packet or to the server again, saying that I received your OK message, and that browser is ready to receive data from your side. So here again, it will set the ACK flag to one. So the minute difference between this is in the SYN ACK step. As I said, it will have an address, right? The SYN packet will have an address. Now this SYN ACK packet will have another address, and the address's last bit is set to one, or the last bit is added to one. One is added so that the client will know the server side acknowledgement is okay. Now in the third step, this app will set this address to one. So the address here and the address here is different. And here it will set the syntax addresses is one, and here it will set this address to one, the last bit to one, so that this way a connection is established. So this is called the three-way handshake. The first is synchronized, second one is synchronized acknowledge, and the third one is acknowledge. So this after this everything is okay, there is a secure connection, and you can transfer data through this connection. Now I'm going to talk about HTTP request. After this connection is done, we are going to send a request for the resources that you need. A request is HTTP is yet another protocol used to transfer data, or as I said, different kinds of files are available. So HTML files, video files, image files, and sometimes applications, and so on. So different types of files should be sent through to different computers. So that is monitored by this HTTP protocol. Now, after the connection is set, the HTTP request is sent from the client side. So there are few request methods. So request methods specify the action the client wants the server to perform. So let's take an example. Let's take you want to see there's a website and there are four get methods. Sorry, four request methods. One is get, post, put, and delete. Let's say you have a website and you want to add something to that website. So let's say you want to, you say Facebook, right? So you have to add something to Facebook. You are posting something to Facebook, and sometimes you want to get something. You wanted to know the location of this particular restaurant, and you want to delete. So let's say you want to delete your post, and you want to modify. Let's say you are going to modify your status, your I don't know, your workplace position or something, right? So there are different processes or different steps that you want to do in a website. So this HTTP request will have different request methods for each thing that you want to do. If you want to post something, it has a different tag. If you want to get something, it has a different. If you want to delete something, you have a different tag. And if you want to modify something, you have a different tag. And there are many other tags as well. The most commonly used ones are these four methods. So this is the get method, this is the post method, put method, delete method. So the get method, I have given you an example of this from the website. So let's say you want to get the location of this particular restaurant that you saw on your feed. So then you are going to use the get method to get the information from that website. Now you want to post something. Let's say you want to post a picture. So a post method is used to post pictures or post something in the specific website that you need. Now sorry, now put is used to modify something that is already there. So you want to modify your status so that you use put, there is a put method in that HTTP request for you to modify something. And you want to delete a post. So in this HTTP request, the method is mentioned as delete for you to delete something. Also, if you are familiar with something about web development or you have been doing, your HTML, CSS and everything, sometimes you put method is equal to get, right? So method is equal to post in the well. So this is actually why you're doing that for the website, for the server to know what you're going to do or what you want to do in that website that you're accessing. So that is why you use get or post or put or delete while coding in your HTML. Now, after your method is done, the request URI, the request URI is added in a HTTP request. So first you have a request method. You will add what kind of process you are going to do in that website. Then you have a request URI. URI is a uniform resource identifier. So it's quite different from URL. URL is said to be a type of URI. URI has the specific address the client wants to access. It has domain name, path, and any query parameters. Query parameters include sometimes if you type and if you put enter, you can see question mark and everything. Or sometimes when you search for something, let's say you're searching for weather today, after you click enter in the URL space, you can actually see weather plus something plus and so on. So those are and slash and question marks and hashes. Those are all involved. So that is a URL, but URI won't have those specific details. It might not have, it is not necessary. So URI is called the Uniform Resource Identifier. And this HTTP request will have this URI. And this request will also have HTTP version. So HTTP is a protocol, as I mentioned. So this protocol is used to transfer different kinds of data. For example, videos, for example, emails or HTML files and so on. So HTTP protocol has different versions. So when first the internet was introduced, the HTTP, there was not any versions involved. the plain HTTP was there, and it was simpler. It is faster if you use it now, but you can't do. There was not many types or many types of data that can be sent through this protocol. So after the beginning of the internet, something called standardization happened, meaning they started to standardize everything. Not any request or anything can be sent through any form. So that everybody can use the specific it'll be easier for everybody and there won't be any confusion. They start upgrading it. So HTTP 1.1 has happened. HTTP 2 has happened. So it's just like every version is the improvement of the previous version. So an HTTP request would have the specific HTTP version for the sorry, for the server to know what kind of HTTP request it is and what kind of protocol to follow so that there won't be any hassle while while sending the data from the server to the client. So it will have the headers and request body as well. So as we have seen in the packets, the headers in the body does similar jobs. So the headers will have information about the request. So it will have content types or cookies is basically something like cache so that if you have already gone to the website, if you have preferred options in the websites in your browser, cookies is something you say you accept all cookies, right? So if you do that, actually you're allowing the website to remember what you have done in that website when you have previously visited that website. So HTTP will have these headers, will have all this caching preferences is basically whether you want to store it or not, whether you have like sometimes you save passwords, right? So which means that yes, I want to store this, I want to put this in the memory, I want to save this password for future use. Sometimes you don't, and so on. And then authentication details and everything, content type. So as I said, image or text file or something. Now it will have the request body. So request body is the HTTP methods, something like get or put. I want to get something, I want to post something, I want to delete something. And also the data that sys has sent to the server for the server to give back the information properly. So this is what the HTTP request is. So HTTP, you went to your computer, you typed the URL, the domain name resolution happened, and you found the IP address. And after you find the IP address, you establish the connection using the TCP three-way handshake. And after there is a connection, you are sending a request. So this is the HTTP request. Will have specific methods that you want to use, specific it will have the exact identifier URI. It will have the URI, it will have the path, it will have the location. It will have the version of the HTTP. It will have what kind of version that is used so that there is not any hassle. And it will have a header which has all the memory information, keys, content names, image or text files. And it will have the request bodies saying that I want to do this specific task in that website. So this is the request. After this, we are going to see the server processing. So the server received this request and the server wants to check where the information is available, which part of the server it is available. And there are some steps involved in the server side. So in the web server processing, first what it will do is it will pass the HTTP request. Parsing is a term used to uh, parsing is the meaning of parsing is basically converting the request into something else so that the server can actually process. So we are going to see what processing it in a bit in the end, but I'll tell you in like one line. It is basically something like when you code, you type as letters and words, right? But it is processed or it is parsed into different things, and it is then complete. So this is what parsing is. The web server first passes the HTTP request will be the method will be, let's say the method is get. You want to get something. So the server will be like, okay, there's a get method. Now what does it want to get? What's content type? I want to get that image and so on. So the web server passes the HTTP request to extract information from the request method. As I said, it will first see in the headers have the request methods and everything, right? So it will see, okay, I want to get something, so I have to go to this specific spot and do these kind of steps in one. Or else, if it is a delete something, I have to go to this specific spot, delete something, and it will have the UR requested URI. URI is the location and the headers and any data request. So this parsing first happens, which means it is deconstructing the message for the server to better understand what it has to do. Now, after it deconstructs the HTTP request, it is locating the resource. So you have sent the request URI. So and it will go to that specific URI in the database, and then it will search for that website that you're looking on the data that you're looking. Now, this resource can be a web page or a video or a script or any type of content. After that, after it goes to that location, now the processing happens. So it reaches the location, you have the data and the websites there, and depending on the method, see if it is a get method, it tries to retrieve content from the website, and if it is a delete method, it tries to remove information in that website, and so on. The processing, the request is processed, the information is taken from the website, and so on. After the information is taken, it generates the HTTP response. So HTTP response will be like, hey, I have this particular file and I'm going to send this to you. It is, I have it, I don't have it, I have done it, or there's some, there are some errors, I couldn't do it properly, it's only half it, or something like that. It has to send information or the data, and it will send to the client. So that is the HTTP response. So this is the server-side processing after the server receives the request. So it receives the request, it deconstructs the message saying that first I have to get it, I have to go to a specific location, I have to do these specific tasks involved, and I have to return it back using the specific version of HTTP and so on. So after that, it goes to that URI, to that location where the website is or the data information is stored, and after it goes to a particular location, it searches for the website, and then depending on the method, it does that operation on that website, and after it is done, it sends back a response. So it sends back a HTTP response. So HTTP response again has a structure. First, it has the status line. So status line, the first line of the HTTP response, the status line saying that 200 okay. So this is the status message, and this is the message it is a message in the human readable format like words. So generally, if you have noticed, if it is in 200s, which means that yes, it is okay, I have found it. And if it is in the 300, I have found it, but there are some trouble load. I have found it, it is there, but it is somewhat not, it is waiting or something. And 400 meaning the website has actually not there, it is not there, and 500 is there are different codes. So 200 is okay, 400 error not found, right? So 400 is not found. 300 is there are some other version of it, not the particular thing that you wanted. And 500 is the website is actually crashed there. Now, the response body. So this body contains the actual data that you are trying to retrieve from the server. So if the client requested an HTML page, then the response body will have the code for the HTML page that will be sent through the optical fiber cables using packets. So it will have code means not the code that you write saying like HTML head or body. It will have bits that will be sent uh, through the optical fiber cables. And then once the HTTP response is fully assembled, the web server sends it back to the client over the established TCP connection. So it will assemble the HTTP response. So the first line is status line. It will be like, yes, it is there. No, some other modification is there. Like, no, it is not there. Or the server has crashed. Now it will have the header saying that the following content will be in this length or this form for you to, and then you have to like construct it in this way for you to display it in your browser. Then after that, the body will be there, where the actual content is present in the form of binary data, zeros and ones, for it to send through the internet. After it is all constructed, after the response is constructed, the server sends the response through the TCP connection. The TCP connection that we have made using the three-way handshake. So after the HTTP response, you have done everything. So this is the last step of this whole process. So you have done everything. You have gone. You type the URL. You opened your machine. You connected to the internet. You type the URL, and this URL is connected to the IP address. It is resolved. Connection is made, and you're sending a request, and then there is some processing in the server side, and then they are sending you a response, and after the response is sent, the response has content in the content and browser or Chrome or Firefox is receiving that particular content and parsing it. As I said, parsing is basically deconstructing the message that they have got for it to process it properly in an efficient manner. So your web browser has this ability to parse the content. So parsing is basically first what is parsing? So parsing is basically it receives the response containing, let's say, HTML here resources for the web page. So it will analyze and convert the program, convert the content received to a form where the web browser can actually read it and display it in your screen. So this process, there's a small process called tokenization. So token is basically the smallest part of a code, like something like the alphabet for the English language. So token is the smallest part of the code. Now a lexical analysis is done. It will read through the code, it will read through everything, it will see what are the keywords. So what are the keywords, what are the functions, and what are comments, that is what are the comments, and it will check through everything. It will see the tokenization, it will make it as different tokens. So in a HTML file, if you know the basic structure of HTML, first you have the HTML tag. First you have the doc type. Sorry, first you have the doc type. You can't forget the doc type. So first you have the doc type, then you have the HTML tag, and then you have the start tag, and you have the end tag, and sometimes you have the self-closing tags where you don't need the end tag, and then you add comments. So lexical analysis means it will read through everything. It will see if there is a greater than less than symbol involved, which is a start tag. And then if there is a slash involved, then it is the end tag, and so on. And it will create something called the DOM tree, or the document object model tree. Tree is a hierarchical data structure, which means there's parent and child. It is again another topic. So it is some similar to how do you say, after this comes, and after this comes. It is something. The structure is usually used to know the data, is used to know some data. Like, let's say I want to store something in a way that first there is this, and only through this I can access this, and after this it comes this in a hierarchical manner. So that is a tree structure. And after that tokenization process, the DOM tree is made. So this is an example of the DOM tree. So first the document is there, and then the root element, there's a HTML element. So first it will be like I have to go to the HTML, and then there is a head element. So HTML generally has the head and the body. So the HTML element head is there, and this head will have title and then meta. Meta will have sometimes you will link CSS styles to this HTML, so it will have all these. After this, I have to go to element body, and the element body will have headers and paragraphs and so on. So this is the DOM tree. So this web browser will create will pass everything, will create a DOM tree. And using this DOM tree, you can efficiently display it in your screen. So first, sometimes if you have noticed, when you don't have a very good internet connection, you'll only see so basic skeleton. You only there will be let's say if you're loading Amazon, right? And if you don't have the internet, if you have noticed sometimes you won't see anything. You won't see the images. You won't align it. You'll just have some links saying that home, then fashion, and then accessories, and so on. And if you click that link, it will actually work. But you can't see the images. You can't see the alignment. You can't see first there is a search bar and everything. You can't see any of that. You only see the bare HTML page. So why that happens is because when there is a low internet connection, which means it is not very fast. So only the HTML will be loaded, and for the loading the CSS, it will take time. Why is that so? Because here in the DOM tree, you're first passing the HTML document, and after that, sometimes the CSS will be linked somewhere here. You can't load the CSS properly, and JavaScript will be added. Internet stops, it will only have the HTML page instead of the CSS because it can't access the CSS. So for accessing the CSS, after you reach there, again there's some process involved. It will again go to the server, ask for the CSS styles, it will come back and so on. So that's why when there is no internet, it breaks and only the HTML is synced. It is because of this DOM tree where you process the HTML first and then inside the HTML you go to CSS and so on. So this is the end of the whole process involved in the internet or the web. So first you type the URL and then the URL was broken down or resolved to find the IP address or locations of the client and the server. And then after you find that specific location, you establish the connection. So you did a three-way handshake, you synchronized and acknowledged the connection, and then you created a connection. So after the connection was created, you sent a request you sent a HTTP request saying, I want to do this specific kind of task, saying like I want to there are some methods involved. So I wanted to get something, I want to put something. And after that, your server processed your information. It went to the specific location. It searched for that website, and then it did the task that it asked for. And then after that, it is sending again back HTTP response back to your client, having all the information that they asked for. And your client or your computer in your web browser, this your web browser is taking all that information, creating, you're passing it and creating a DOM tree. And then it is saying that first I have to do this HTML, and then after I reach the CSS part, I have to again get the CSS part from the server, and then the whole web page is loaded, and finally you can see the web page, that website that you wanted. So this is the whole process involved in the internet. So I hope this was informative. I hope you got to know about what the background process is, and if you're into web development, you got to know how your website is actually sent and received through the internet. And then I hope this was useful. So if you have any questions, you can ask, you can comment it. If you have any questions. So I hope everything is clear. I hope this was useful, and I hope you got to know about the process involved and what internet is and what the connection is and everything, what are packets and how data is sent. I hope this was informative. Thank you guys. Thank you for spending your time, and we will end it.